Okay, so this is the resource that I made in order to explain a key principle. My topic is loci and rolling circles. So one of the key principles that I decided to look at was just visualizing rolling circles and being able to plot points. So one of the main things that students might find difficult, I found difficult myself, was actually visualizing this rolling circle moving and what points would be where depending on a certain location. So say point P here on the circle, the inner side one, if the circle was to rotate half a revolution, so 6 would be half a revolution, so rotate 6 to the 6th stage, point P would end up here. Now if you were to ask me beforehand where is it going to end up, I'd have to think about it quite a bit before actually giving an answer. But with something simple like this and a resource like this, it's very easy. Students will be able to come up or use it in the classroom if they're doing a question, just to help them when they get first get introduced to the topic. Another thing they could do is to actually draw a locus. So if we say that our point P is on the very edge of this circle here, and we want to draw the locus that follows that point P as it rotates clockwise and rolls along this fixed line. So on the first roll, it's simply going to roll to point 1, and if we line that up with the axis, we can just mark our first point, and we can go on to point 2, mark P, point 3, mark P, point 4, be in there, 5, and we go on and mark every single one of them, 6, P will hit the line there, point 8, 9, 10 will be in there, 11, and finally a full rotation bring us to there. So I can take that off, and then I can get my pencil, because if I was to actually make this resource to be a lot more efficient, I'd make it a whiteboard and cut out a groove in it, so I can then just wipe it out or whatever. But at the moment I'm just using foam board, just something that I had in the house. So I have all these points, my first, second, third, the whole way around. I can just sketch my curve as accurately as I can. It does a little bit of a loop here, and back up again. I can just draw that in with another colour just to highlight even more. And then there we have it. We have our locus, and that locus is called a cycloid as well because it's on a fixed line. But I just think that that'd be a good resource to have in the classroom when first introducing the topic, because it's just a little bit easier for students to be able to look at that. Even when they have the curve in, it's actually even better to look at the point and see how that path is created from following that point P. So that's my resource, and that's it.